Today we're looking at a bunch of different area formulas, starting with our circle. So if here's our circle, here's the center, going out to a point on the circle, that would be our radius. And our area formula uses that radius, so our area equals pi r squared. A little different when we're talking about a sector of a circle. That's like finding an area of this piece of pie. So when we're trying to find just the area of the slice of the circle, right, if this central angle is x degrees or the arc measure is x degrees, we're going to take a fraction of the circle, x degrees, out of the total 360 and multiply that by the normal area formula, pi r squared. Again, remember that that x is the central angle measure, or it would be the same as your arc measure. And when we get to a triangle, I'm going to go ahead and draw an obtuse scalene triangle here. We have to remember that your height must be perpendicular to the base. So if I'm saying this is my base along the bottom, I have to draw in the height on the outside to make that perpendicular there. So I only use this part in blue for the base. This perpendicular length here would be the height. And for the area of a triangle, I have to take 1/2 base times height. Or some of you like to think of it as the base times height divided by 2. When we talk about a square, we have our base times height. But if we think about a square when all 4 sides are congruent, all 4 angles are right angles, your base and your height are really the same length. So you should be familiar with saying, instead of base times height, base times base to get you base squared. For a rectangle, since those sides are different lengths, we have to use base times height. Base and height must be perpendicular. Parallelogram again, base times height. But this time, unlike the rectangle, the base and the height are not just the sides of the figure. So since our parallelogram is like a slanted rectangle, here's my base. You could draw on a height perpendicular to that on the inside there. You could put it on the outside of the shape. As long as it's perpendicular to the base, we are not using those side lengths. Same thing with the rhombus, base times height. Like our slanted square, all 4 of those sides are congruent. This is my base. Again, I could draw that height on the inside, or I could draw that height on the outside as long as it's perpendicular to the base. When we talk about a trapezoid, it doesn't matter if isosceles or ordinary. This will work for either kind of trapezoid. So if this is our trapezoid, remember your parallel sides are your bases. So here's my base 1, base 2. It does not matter as long as those are your parallel sides. Again, with the height, must be perpendicular to those bases, not just going to use those side lengths. Since there's 2 different bases, we're going to find the average of them. Base 1 plus base 2 divided by 2, and then multiply it by the height. It's the average of the bases times the height. Height has a completely different formula since we're not using the bases at all. We're using the diagonals. So your diagonal 1 goes that whole length of that whole segment there. Diagonal 2 is the length of that whole segment in green. This time we're going to multiply together diagonal 1 times diagonal 2, and then divide it by 2. And if you had some sort of irregular figure, maybe it looks something like this. Here's a square and a semicircle and a triangle. Let's find the sum of all the areas of those shapes. So we're just adding up all of those separate areas. When we see some irregular figure on a grid, though, there's a couple important things we have to remember. That I stands for the number of included squares. Those are full squares on the inside. So in this case, my I, I'll rewrite it down here as 5. For B, those are the boundary squares. They're on the edge of the shape. They're not full squares. They're only partial squares. They're like half in, half out. So any square that contains some of the shape's area, we have to count. So in this case, our boundary squares are 18. U is talking about the area of one square. So this would be given to you that the side of one square is 12 inches. So I would have to take, since it's a square, 12 squared, to give me 144. And once I find all of those values, I plug it into the formula. I say A equals my included full squares, half of those boundary squares, since they're half in and half out, and we'll multiply that by the area of each square. So in this case, our formula is taking the 5 plus 1/2 times 18, and then we'll multiply that by 144, and that'll really give us 2016 square inches.